Hello everyone and welcome back to the channel. If you want to stay up to date on my geometry, algebra, or graphing calculator videos, please hit subscribe and turn on notifications and you'll get an alert each time I post a new video. Alright, in this video we're going to talk about rotations in geometry. So a rotation is a transformation in which a figure is turned about a fixed point called the center of rotation. Most of the examples that you will see and that we will do, the center of rotation will be called about the origin. Okay, so we're going to be rotating around or about the origin. Now with rotations, it's similar to translations and reflections in that it's a congruence transformation. So when we rotate a shape, it doesn't change size or shape, it stays congruent. We are simply just moving where it's located. Okay. So there are a couple coordinate rules for rotations, and I would suggest memorizing either one of these. All right, I wouldn't suggest memorizing both clockwise and counterclockwise. It would just depend on what your classroom teacher wants for you to do. I've seen it both ways. I've taught to memorize clockwise and I've taught to memorize counterclockwise, just depending on maybe what our textbook has that we're using for the course, or just whatever your classroom teacher wants you to do. So we will look at both of them, and then we'll refer to counterclockwise in this video. So for clockwise rotations, we have a 90 degree, a 180 degree, and a 270 degree coordinate rule. Okay, so for 90 degrees, notice x, y is like our starting coordinate, and we are making our x coordinate opposite, and then we flip the position. So it's a y comma opposite of x. For 180, the x and y stay in the same place, they just both become opposite, so negative x, negative y. And for 270, similar to a 90 degree rotation, we make y opposite this time and we still flip the position of those terms. So if you'll notice, the difference between clockwise and counterclockwise is not much. Basically, 180 is the same, right? Because if you're rotating 180 this way or 180 this way, you're still going to end up in the same place. So the same coordinate rule applies there. And for clockwise, a 90 degree clockwise would be the same as a 270 counterclockwise. And a 270 clockwise rotation would be the same as a 90 degree counterclockwise, okay? So the good thing about these rotations is that our coordinate plane is split into 4 quadrants, right? So if we have a shape in quadrant 1 and we want to rotate it 270 degrees, depending on clockwise or counterclockwise, just know that it should be in either quadrant 2 or quadrant 4, depending on which way our rotation was, right? If it's clockwise, then we're going to end up in quadrant number 2, and if it's counterclockwise, we're going to end up in quadrant number 4. So if you kind of remember that, then it should help you with your graphing, okay? All right, so we're going to look at one example, and this one involves a 90 degree counterclockwise rotation. So in all the questions you do, it should tell you either counterclockwise or clockwise in the specific question. If it doesn't, maybe there was some kind of note at the beginning of the lesson in whatever textbook you're doing, or maybe your teacher referred to and said, hey, from here on out, we are going to use clockwise rotation or counterclockwise unless it says otherwise, okay? So for this example, it says graph triangle JKL with vertices J 3, 1, 4, 6, and 6, 5. And its image after a 90 degree counterclockwise rotation about the origin. So I'm going to go ahead and graph these 3 vertices and draw our triangle, and then we'll apply the coordinate rules for this rotation. So J is 1, 2, 3, 1. So there's J. K is 4, 1, 2, 3, 4, 5, 4, 6. And L is 6, 1, 2, 3, 4, 5. Okay. So J to K to L and back to J. All right, so we have our triangle. And so now we want to do a 90 degree counterclockwise rotation. Okay, so we can kind of make this note to help us know what our coordinates are going to do. So if we go back up and we're going to say counterclockwise 90 degree, right? So this is what we want to reference. So we want to make y opposite and then switch our coordinates. So opposite of y and switch our coordinates, okay? All right, so we're going to look at J, which was 3, 1. And when we rotate it, remember our new shape is going to be J prime, or our new point will be J prime. Okay, so y right now is positive 1, so it's going to become negative 1, comma 3. X stays the same. For K, our starting point is 4, comma 6, so K prime, we will do negative 6, comma 4. And for L, we have 6, 5. So L prime will be negative 5, 6. Okay, so I will switch up my color here. Let's go red, and let's graph our new image. So negative 1, 1, 2, 3. So this is J prime. Negative 6, 2, 3, 4, 5, 6, and 1, 2, 3, 4. And this is K prime. And then negative 5, 1, 2, 3, 4, 5, 6. Oops. Negative 5, negative 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. There we go. And that is L prime. Okay, so let's connect our points. J to K, K to L, and L back to J. All right, so we can see we still have the same shape. We still have the same size of the shape, right? So it's a congruence transformation. And if you notice, right, we wanted to go 90 degrees counterclockwise. So 90 degrees counterclockwise would just end us up one quadrant to the left there in quadrant 2, okay? And that is how you do rotations in geometry.